Hello, and welcome to the Curiox Biosystems webinar. We will have two speakers today, Blanca Ponce-Ngo from Montefiore Medical Center in New York, and Dr. Charles Martin, who is the Director of Marketing at Curiox Biosystems. The presentation will last approximately 25 minutes. Please type your questions in the question box, and they will be addressed at the end of the session. A recording of this webinar will be available shortly after the presentation at curiox.com. Now, without further hesitation, may I introduce Dr. Charles Martin.
Hi, thanks, Sheila. Welcome to our webinar. We're again excited to share more customer results with you. And our main speaker, Blanca, will follow my brief presentation and will share experience and data from her transplant cross-matching work. And many who perform flow cytometry cross-matching will immediately see the value of Laminar Wash in their work based on Blanca's data. So just a little refresher, let's see which step in the flow cytometry workflow causes challenges. And a simple answer to this question is every step. This slide shows a brief overview of a flow assay workflow. A sample is prepared directly from humans, and sometimes they're frozen, and then cells are stained, and in most cases undergoing multiple steps of incubation and washing, and then read on a flow cytometer. The resulting data appears as flow plots, which can be gated accordingly. Now, there are many areas of possible variation: the way cells are handled, particularly in washing, the setting of instrument parameters, laser intensity, detector settings, etc., and how the populations of cells are gated. Any one variation in the workflow will cause changes in the data, potentially leading to a different outcome. So there has been tremendous effort in the flow cytometry community to standardize a workflow and produce robust flow data that can be compared independent of operator time and location. So I want to show a summary of a recent review paper, that's mentioned there in the bottom left, discussing the standardization of flow cytometry to achieve consistency and reproducibility and thereby enhance quantitation. From the previous slide of the workflow, we learned that there are three major components: data analysis, the flow cytometer, and sample prep. Now, fortunately, we have achieved tremendous progress in two out of the three areas. Those are data analysis and flow cytometers. In data analysis, we can now access automated gating and grouping programs, removing human judgments in the analysis. In addition, analysis can be performed significantly faster compared to manual analysis. If you'd like to find out more about this or more resources, we're happy to introduce you to a couple of sources for that. Now, flow cytometers have also improved dramatically. Most new ones have a self-monitoring program and can be easily normalized using commercially available beads and reagents, virtually making them comparable to any other flow cytometer. The most challenging component is sample prep. Now, in this particular review paper, authors claim that we have to apply much more effort for our operators to strictly follow SOPs, which I'm sure is very rigidly adhered to in flow cytometry cross-matching labs, and also to ensure they minimize mistakes and report any deviation. Experts in the field, however, do not necessarily agree. They firmly believe pushing operators is not the best solution. We need a different solution if we want to achieve robust data of flow cytometry. So the Laminar Wash system is positioned to minimize all of the challenges listed under the centrifugation of cells. In a conventional wash process, scientists typically use a centrifuge and a multi-channel pipette. A wash of two centrifugations takes a total of, say, 15 to 20 minutes, depending on what your particular protocol is. In contrast, the Laminar Wash system takes care of the entire wash process automatically in 2 minutes without a centrifuge, and also without centrifugation. Cells do not experience any external forces or stress. So in this slide, I'm going to show a short movie clip of how the Laminar Wash system runs. And in the movie, there's two wells, so down here, that have droplets of green fluorescent polystyrene beads, which are surrogates for cells, and two droplets of dye. And after 20 minutes of rest, the beads settle on the plate, just like cells would. So I'm going to start this movie. So the user would then place the plate in the washer and hit the start button. The plate goes in, and the fluidics head comes down to the plate. In this run, we've lifted the cover of the washer to show the movement of the head and the plate inside. The head has 192 nozzles total, so there's 2 nozzles per well, one for dispensing in each well and one for aspiration in each well, and that's what creates the laminar flow. During the 2-minute operation, it performs 7 cycles each of dispensing and aspiration. So when the wash is complete and the plate comes out, just like it is now, and in the pictures you can see that the food coloring solution, or the dye, is completely gone. The dye represents tagged antibodies, while the green fluorescent beads over here would in this case take the place of cells, and they're retained on the plate. Now, you may wonder how come the dye was washed away while the beads were retained. And just to clarify, the beads are not attached to the plate by any interactions, just as cells aren't attached to the plate by any interactions. They're simply resting on the plate and held there by gravity without any adhesion. And I'll show you in the next slide how this works. So the retention of beads and cells on the plate is based on well-characterized forces of gravity and fluidics, in this case, a laminar flow. And these are very well-known forces in nature. The secret is that the use of each force is on an almost flat, wall-less plate, so we can control the forces. At the bottom of the slide, you can see the working mechanism of cell processing by a laminar wash. The cells are mixed and settled on a plate by gravity, and the settling takes 20 minutes or so, usually during standard incubation periods during a staining protocol. And once the cells are settled, the action of dispensing and aspiration above the cells does not disturb them. The wash solution forms a laminar flow during dispensing and aspiration and minimizes turbulence of the liquid flowing over the settled cells by this laminar flow. The velocity of the fluid becomes almost zero at the surface of the plate, and at the very bottom of the plate where cells are located, the cells are not subjected to any kind of fast flow rate of the wash buffer. And over this thin fluidic layer, right up top, across the top of the cells, washing happens by diffusion rather than turbulence of the fluid, and this is how we can wash the cells without losing them. So interestingly, when we perform an identical dispensing and aspiration in a conventional walled plate, the action of dispensing and aspiration causes great turbulence, which will lift the cells from the bottom of the plate, leading to cell loss. And later I'll show you an example clearly demonstrating what this type of washing is just as efficient as centrifugation-based washing. So in the next couple of slides, I just want to quickly highlight some data we've run with collaborators and customers, and it will complement the data that Blanca will present. So these next couple of slides show optimized laminar wash methods. Every time we work with the customer, we optimize for their specific protocols, although many protocols are very similar. In this case, I'm going to show how the method can retain more cells, particularly cells from tissue samples. So this is actually cells from data from a large CRO. And in this case, and in all cases, the flow rate of dispensing and aspiration can be adjusted to optimize, as we've done here. Here we show improved immunophenotyping data for tumor infiltrating lymphocytes, or TILs, and this work was done again by a very large CRO. So, and this was optimized for this particular lab's protocol. And you can see on the bottom method, which is the laminar wash method, we get higher retention of cells and also higher resolution, especially as you look over to the far right with some of their particular cells of interest. Now this slide also shows enhanced consistency between operators, and this was done by a biotech that's working in cell therapy in California, and it shows enhanced consistency between operators, which they're very interested in because as they get to a manufactured product, they need to be able to consistently produce cells that are going to be used for therapeutic. And you can see there's enhanced consistency, especially among rare cell populations, which they're very interested in. We've also heard that consistency among operators is of particular interest for cross-matching labs. And finally, I just want to show a highlight slide from a previous webinar by Dr. Prabhakar Puthetti at the Rogosin Institute. And this is also from a cross-matching lab. In his studies, he found that the laminar wash method consistently produces lower CVs than the conventional centrifugation method. And as a reminder, the full webinar is available at www.curiox.com, just like this webinar will be. And now this concludes my introduction of the laminar wash system and a few highlights of customer data. And I'm now going to turn my presentation over to Blanca.
Thank you, Charles, for the nice introduction. Good morning. My name is Blanca Ponce-Ngo, and I'm the lab manager at the Transplant Immunology Lab in Montefiore Medical Center in the Bronx, New York. Thank you for joining me today and giving me the opportunity to share with you my experience with Curiox's laminar wash system. My director, Dr. Adriana Kolovai, and I were looking for an automated plate washer that we could use in our lab. At Montefiore, we receive approximately 700 patient samples per month and perform an average of 5 crossmatches a day. The precision and turnaround time for flow crossmatches are some of the major factors we considered for a new technology. Our lab also just started participating in the NKR program. The NKR program allows for the exchange of living donor kidneys across the country by registering a pool of incompatible living donors. The program requires frozen cells to be used for all initial flow crossmatches. So we needed a technology that would help us generate interpretable flow crossmatch data from the challenges of using fragile frozen cells. I was introduced to the Curiox Laminar Wash system at the previous annual ASHI meeting in Baltimore and have been validating it against our current method. I would first just like to show you what a flow crossmatch protocol generally involves in most labs. It starts with isolation of lymphocytes from blood. We use easy-set magnetic beads in our lab, and we suspend the lymphocytes in 20% FCS medium. The lymphocytes are then incubated with patient and control sera, usually for half an hour at room temp. Then there is a first set of washes. Afterwards, the cell serum suspensions are incubated with a cocktail of CD3, CD19, and FITC, usually for 20 minutes at 4 degrees, followed by a second set of washes. And then finally, the samples are run on the flow cytometer. The Laminar Wash system was used only to replace the 2 sets of washes. And I use the same flow wash buffer for the Laminar Wash as our current method. Our flow wash buffer consists of PBS, 1% fetal calf serum, or FCS, and 0.1% sodium azide. Our current method involves the tedious washing of donor B and T cells in flow crossmatches by centrifugation, removing the supernatant by aspirating with a pressurized pipette, and then adding the flow wash buffer in tubes. This wash step is repeated several times for each crossmatch, damaging the cells after each wash cycle. Frozen cells, or cells that are frozen and then thawed to be used for an NKR crossmatch, are known to be even more fragile than cells that were isolated from fresh peripheral blood. When we came across the Curiox laminar washer, we were intrigued by the no centrifuge handling of suspension cells throughout the crossmatch incubation step, and simple automation by laminar washing without aerosolized flicking. We gave a few thoughts on validating this new method, and we started by studying the lowest cell number that we can perform a comparable crossmatch. Cell loss is a predominant problem with centrifuge-type washing. And then I performed a FITC titration experiment to determine whether a lab could continue to use our current FITC dilution of 1 to 400 when using the Laminar Wash system. I also trained my newest tech, who only has 1 year of lab experience, to plate a crossmatch using the Laminar Wash system. I remember Dr. Prabhakar's previous webinar on a Laminar Wash system that showed there was minimal variation of test results from tech to tech and from test run to test run, and between replicate wells. Technology transfer between operators can affect our process and our precision. I would like to start off this presentation with this angle, and I will conclude my webinar with some new data that has influenced me to continue working with the Laminar Wash system in hope of revolutionizing our approach to challenging samples for histocompatibility testing. But before I discuss my intra and inter testing results, I would like to first show you here on the top row the B and T lymphocyte population after being washed in the Laminar Wash system for a flow crossmatch. The cell populations shown on the bottom were washed using the current method. These cells were incubated with negative control sera. In this slide, the cells were incubated with the positive control sera. Again, the top row represents the cells that were washed with the laminar flow washer, and the bottom row represents the cells that were washed using the current method. All of these cells were isolated from a donor's peripheral blood on the day of my test. As you can see, most of B and T lymphocyte populations look normal, or as expected. They appeared intact and viable even after several rounds of washing in the Laminar Wash system. Forward scatter and side scatter characteristics remain the same. The cell surface of lymphocytes need to be intact and stable in order for their Fc cell surface receptors to bind to their respective conjugate markers, such as CD19 for B cells, CD3 for T cells, and FITC for anti-IgG, the most important antibody in the field of HLA and transplant. When bound, these markers emit strong mean fluorescence signals that are measured as MF units in a flow cytometer. The higher the signal of IgG FITC from the cell emitted, the higher the mean channel, or MC, units will be. The greater the difference in MC between your negative control and your patient's serum determines whether your donor cells are compatible with the patient. And this is why a crossmatch is the most important test before conducting an organ transplant. Our lab at Montefiore currently performs crossmatches for kidney, heart, lung, and pancreatic transplants. One of the disadvantages of our current wash method, or of all non-automated washes, is that there is always variation in MCF results generated from tech to tech and from plate to plate. Our lab has had the good experience of training several lab techs, and at one point, we have 3 to 4 techs routinely perform flow crossmatch. As our hospital runs crucial samples several times a day, we face the challenge of consistency of processing these samples, and especially with washing. But with the Laminar Wash system, these variations are eliminated. Every sample well on the DA plate will receive the same exact wash conditions, regardless of which tech is running the crossmatch, and at different times of the day. The Laminar Wash system has proven operator consistency, inter and intra plating, as shown in this table. CVs are minimal between sample wells and consistent from day to day and from tech to tech. We were highly encouraged that it was reproducible from what we saw from Dr. Prabhakar's webinar. After reproducing his results, I decided to take it a step further and determine whether the Laminar Wash system could be operated by a tech who had minimal lab experience. My lab tech, Aros Kwama, has only had 1 year of lab experience, so I wanted to see whether even he would be fully capable of using the Laminar Wash system and Laminar Wash Plate for flow crossmatches. He and I plated negative and positive control serum against the same donor cells and used the Laminar Wash system one after another. We both completed the crossmatch within 2 hours and produced comparable results. As you can see from the bar graph, he and I produced almost the same MCs for both B and T cells. The technology transfer between an experienced and new user was relatively easy and basically required little to no technical expertise to operate the washer. I was really pleased to see that all of our operators could use the Laminar washer. So many of you know how it feels when you're working on a crossmatch and you receive very little or very poor quality of donor samples to use. And the transplant surgeon is already calling you in your lab and asking for crossmatch results because he's waiting in the OR and ready to transplant the patient. Don't you just love how they forget that our lab tests take up to 6 hours to complete? We are not a clinical chemistry lab that can obtain instant results from an automated instrument. So what do? You rely on all the HLA experience you have to isolate as many B and T lymphocytes from your donor's tiny lymph node or small piece of spleen or 5 mL of blood. So you pull it off, but you still need to cross your fingers and hope that your cells will remain intact and stable throughout your washing cycles. So you hold your breath as your first sample is acquired on the cytometer after 3 to 6 hours of labor, and you see only 10 tiny dots in your gate. an invalid cross-match result, you have nothing to report to the transplant surgeon, nothing to predict whether the patient will be fine after the transplant. So it's really important to determine how low can we go with the cell count that is used for our cross-matches using the Laminar Wash system. In this cell titration experiment, I tested cell concentrations as low as 50,000 cells per well to as high as 200,000 cells per well. All cell titers were compared. We concluded that we can use 50,000 cells if we needed to with the Laminar Wash system. So we can continue to use our current protocol of 100,000 cells per sample. When running even with 50,000 cells per sample on the cytometer, the number of total engaged B and T cells still reached the same number of events. As our current method that uses 100,000 cells. And also the acquisition time per sample remained the same. And cross-match results were the same between the Laminar Wash system method and our current method, and at all cell titers. This concludes that you can use the Curiox Laminar Wash system whenever you have low cell count. So there is no need to request for more donor tissue or blood from your donor network. So there will be no more delay in allocation of the donor organ or a delay in transplant. After confirming that we could still use 100,000 cells per sample in our cross-matches using the Laminar Wash system, we also wanted to confirm that we could continue to use the 1 to 400 FITC dilution. So I had to perform a FITC titer experiment that tested dilutions of 1 to 50, 1 to 100, 1 to 200, 1 to 400, and 1 to 800. If we look at the left and right graph, the purple line represents the B-positive control MCF. The green line represents the T-positive control MCF. The orange line represents the B-cell channel shift. The light blue line represents the T-cell channel shift. The red line represents the B-negative control MCF, and the blue line represents the T-negative control MCF. The data concluded that there was minimal loss of FITC signal at 1 to 400 in both the spleen and blood-derived cells. And the table here shows that the MCFs were comparable for both methods in both spleen and blood. The MCFs for the blood are shown in blue, while the MCFs for the spleen are shown in green. So we could still use the 1 to 400 for both tissue and blood-derived lymphocytes with the Laminar Wash system. So after being able to generate the same cross-match results using both the current method and the new method using lymphocytes isolated from fresh blood, we were ready to try out frozen cells. We froze cells overnight from a previous donor's blood and thawed the next day to start another experiment. The top row in this slide shows the thawed B and T lymphocyte populations after being washed in the Laminar Wash system. The cells are intact and stable. Notice they look comparable to the cell populations of the cells that were isolated from fresh blood in the first slide of my webinar. And once again, the frozen cells appear the same when bound to both the negative and positive control serum. So in this slide here, I'd like to show you the crossmatch results, that they were just as expected for frozen cells. Negative crossmatch for the negative control serum and positive crossmatch for the positive control serum. I also tested frozen cells derived from the lymph nodes. These results are indicated on the bottom row. I got the same crossmatch results as the frozen cells from blood, or the results in the second row, and the same results as the fresh cells from the blood, the results in the top row. So the same protocol using the Laminar Wash system can be used for lymphocytes isolated from tissue as well. This was one of our first experiments using frozen cells, so I used 1 to 40 FITC dilution and plated 250,000 cells per well. first just to see whether frozen cells could even generate crossmatch results. Later experiments were done with 1 to 450 dilution and lower cell counts, and were also successful. And frozen cells acquisition time on the cytometer occurred at the same speed and with the same number of total gated events as cells washed with the current method. In our lab, like some other HLA labs, lymphocytes are incubated with Pronase before flow crossmatch is begun. Pronase is an enzymatic treatment to diminish nonspecific binding. Pronase is known to remove Fc receptors on the surface of B cells to prevent false positive B cell crossmatches. The drawbacks of Pronase treatment is that it requires more effort to maintain cell viability and requires additional incubation time. But the laminar washing might offer a different washing technique that circumvents this nonspecific binding effect. When we tested the negative and positive control serums against donor cells that were either treated or not treated with Pronase, we found interesting results for the B cell crossmatches. Background that was commonly seen in B cell crossmatches was now eliminated using the laminar wash system because the difference between the T and B cell NCF, also known as the delta B, in the negative control crossmatch was significantly lower, almost zero, when using the laminar wash system. This is indicated in blue in the table and on the bar graph below. The green indicates the results using the old method. This difference was observed in multiple experiments that we did in our lab. We worked closely with the Curiox team about this finding. The laminar plates allow cells to be washed without pelleting, which is a big difference, allowing direct exposure of buffer to the resting cells. From some of their earlier technology expose and publications, they show that laminar washing allows the effective diffusion rate for nonspecific binding proteins, including antibodies. And it was tested for a large variety of sample types, used regularly for flow to imaging purposes. Recently, they have shown some newer data on washing tumor-related debris, which improved the study for viable cells, including lymphocytes. But to conclude, the laminar washer produces consistent, reliable, and reproducible results. The laminar washer can be used by all techs. The laminar washer can be used for both fresh and frozen cells using the same protocol or same FITC dilution and cell count. This is especially important for all HLA labs participating in the NKR program. The laminar washer can be used when cell count is very low. The laminar washer saves time by replacing centrifugation and Pronase treatment. Laminar washer offers a gentler wash method that might be used to prevent unexpected positive flow crossmatches. This theory is currently being tested in our lab. Maybe no more auto crossmatches will be necessary. There are also other benefits from using the Curiox laminar flow washer. For example, it's cost effective because it doesn't require centrifuge. There's less tech needed if one tech can finish 3 separate flow crossmatches, one after another per shift. Each crossmatch takes only an average of 2.5 hours, even when I had 22 samples. The washer requires less space than centrifuges. It is safer than flicking, so you have minimal exposure to infectious materials. It's user-friendly and requires minimal maintenance, and it prevents cross-contamination of samples. I would like to take this moment to dedicate my first live webinar to my 2 biggest fans, my godfather Dominic and my grandma Blanca. They recently passed away this year. My godfather taught me to never stop learning, while my grandmother taught me to never be afraid to face any challenge. And I think this webinar is a product of these 2 qualities they instilled in me. I would also like to thank some very special people. I never would have been able to do this without them. Thank you to my lab director, Dr. Adriana Colabai, who is my mentor and sometimes my lawyer. She knows what I mean. Thank you so much to my tech, Elise Kaglar, also known as the Sherlock Holmes of our lab. While I collected data using the laminar wash system, she collected all the data using our current method to provide results that we could compare. She also did an outstanding job isolating all of the cells, including the frozen cells. Thank you, Elise. I hope to collect more data with you. And Arrows, who we call the professor. He represented the tech with the 1-year experience who used the Laminar Wash system to compare results with me. Thank you, Arrows. And lastly, I thank my husband, Tommy, and my 2 sons, Ryan and Cody, for being patient with me while I stayed back at work to finish these experiments and prepare for this webinar. You guys are the best. And one last thing I'd like to say is that I've always been an advocate for new technology that would streamline the workload in labs. But most of all, I am an advocate for new technology that could save lives and lead to more transplants. As an advocate for lab technology, I'm so happy and grateful to have had the pleasure of introducing you to Curiox Laminar Wash system and sharing with you the promising data that was collected from it. I highly recommend your labs to try it out, as it could be used outside the scope of HLA testing. Thank you. And in this slide, this is my older son, Ryan, giving me a thumbs up. So I hope you all are feeling the same way too.
Oh, thank you so much, Blanca. This was wonderful. Really appreciate it. We do have some questions coming in. The first one, what is your backup method in case the laminar flow washer is not functioning or in need of repair?
I think the great thing is that we can always fall back on our current method and just go back to centrifugation and flicking the plate.
We also have a comment. Thank you very much. This was very informative and incredibly well put.
Thank you.
Nice. Another question, is your IgG FITC monoclonal or polyclonal?
It is polyclonal.
Thank you. Question from Jamie, how much does the laminar washer cost?
So the list price is just a hair under 50,000, but we also have a newer system coming out that's might be better for lower throughput labs. That's going to be a lot more affordable.
Thank you. From Kelly, what is your hypothesis regarding the impact of the new method on B cell surface expression? No need for pronase.
We do have a hypothesis, but of course we're going to continue doing more experiments. But our hypothesis basically is that with the old method, or our current method, involves centrifugation and, generally a more aggressive type of washing, whereas the Laminar Wash system offers a gentler washing method. So we're thinking that with the more aggressive or current method of washing, there might be some breakage of the calf serum that's blocking the FC receptors. As many of you know, in the HLA field, FCS or fetal calf serum is added to media buffer to help block interference in crossmatches or minimize backgrounds, especially in B cells. So with the Laminar Wash system, we're thinking that it's such a gentle wash that this FCS that's bound to the FC receptors is probably intact, remains bound to these FC receptors during the washing step. So that's our theory.
Great.
So we'd love to hear more hypotheses from every one of you, especially in the HLA field. If you have any, well, welcome.
So I don't see any other questions. If you still have questions or questions come up later, feel free to email us or just go on our website and send us the question through our contact form. And thank you so much, Blanca. This was an excellent webinar. We know it was very helpful to the HLA community, so thank you so much.